Alright class, today we are going to do inverses of secant, cosecant, and cotangent, the reciprocal functions of sine, cosine, and tangent. So, first off, just to remind yourselves that secant is 1 over cosine of theta, cosecant is 1 over sine of theta, and cotangent is 1 over tangent of theta. Now, that's when we're looking for the actual values. When we're finding angles, you only have to flip the values, and I'm going to show you that with the examples down below. But before we do that, we have to define the outputs that we're going to get with secant inverse, cosecant inverse, and cotangent inverse. So, secant inverse will have the same outputs as cosine, because remember this goes like with cosine. So your answer will be between 0 and pi, just like cosine. Cosecant inverse, remember, goes with sine. And sine inverse, if you remember correctly, gave you an angle between negative pi over 2 and pi over 2. So those are the same as the originals. This is where it gets a little weird, and it's because of a graph. So tangent we did between negative pi over 2 and pi over 2 like sine. However, cotangent inverse, or inverse cotangent I should say, is not like tangent. It's like cosine and secant. The output is going to be between 0 and pi. And that's because the graph is connected from 0 to pi. There's an asymptote at 0, so we don't go from negative pi over 2 to pi over 2 because graphically we don't jump over that undefined mark. So this is not the same, I'm going to make a note, not the same as inverse tangent. Okay, so that's the only thing different here besides that. So let's look at how these work. I'm going to just rewrite all these before we begin. So what you want to do is you want to flip these numbers back. Okay? You want to just flip these back. So instead of cosecant inverse of 2, I want to know what the sine inverse of 1/2 is. So I'm basically rewriting the problem and turning it into sine. Here I'm going to rewrite the problem and turn it into inverse tangent, but when you flip a 1, you still get a 1. Now here, guys, I know I've been not rationalizing these, so you can think of this actually as 2 over root 3, so that when we turn it into a cosine inverse, it goes back to root 3 over 2. Again, I'm not doing any math yet. I am just rewriting them back into the other ones. And then we have to figure out which one's going to be the problem. And actually, it's going to be number or letter D. So we need to flip this, negative root 3. So tangent inverse is 1 over negative root 3, or negative 1 over root 3. Sorry about that. Cosecant goes with sine inverse again. Again, this is just like 2 over root 3. So we have negative root 3 over 2. And secant goes with cosine. And by the way, this is the same thing as 2 over root 2, when you see that. So it goes back to root 2 over 2. So all I've done was I've taken the reciprocal inverses and written them back as the 3 that we have learned and know. The only one that's going to be a problem is letter D, because cotangent inverse and tangent inverse, when it's negative, are in different quadrants. This is going to have to be in quadrant 2, even though this gives us an answer in quadrant 4. But we'll deal with that later. So now you just kind of do what you need to do, figure out what angle sine is 1/2. You can use the hand trick, you can write your unit circle out. You should note that sine is 1/2 at pi over 6. Tangent is 1 when x and y are the same, and that happens at pi over 4 because they're both root 2 over 2. Cosine is root 3 over 2 when sine is 1/2, so it's actually another pi over 6 again. Okay, so those are just kind of getting the answers. This one's a little weird. If we were to do this problem yesterday, or the day before, we would have said, well, 1 over root 3, that happens at a 30-degree angle, because again, It's the y is smaller than the x. The y was 1/2. The x is root 3 over 2. And we would have said negative pi over 6 for this answer. However, we need the quadrant 2 angle that's like negative pi over 6. Right? So, I have to figure out in quadrant 2 what has a pi over 6 reference angle, and hopefully you guys realize that is 5 pi over 6 over in quadrant 2. If you need help, you can draw it. Instead of here, we're here. Again, this is 6/6, so that's 5/6. These other ones, this will be in quadrant 4, a negative angle. Sine is root 3 over 2 at pi over 3. So we just put a negative in front of that. And then cosine is, I should probably write an inverse here. Somehow that didn't write. Cosine inverse of root 2 over 2, or inverse cosine I should say, is pi over 4. Okay. So, that's how you do inverses with the reciprocal functions. You flip the numbers and turn it back into the 3 inverses that we know. To do solving, and by the way, I'm going to change this problem. So if you have this note sheet, make this one equal to 2 pi. So, this is going forward, so we don't have to do much. We would just solve for this, which means we divide by 6. And then we would do cosine or cosecant to both sides. So we get x is equal to the cosecant of pi over 6. This is just from before the quiz, knowing the value of cosecant at pi over 6. Well, in order to know the value of cosecant at pi over 6, you need to know the value of sine at pi over 6, which is 1/2. So x equals the flip of 1/2, which is 2. Over here, we have secant inverse of x equals pi over 2. Secant both sides, we get x is equal to the secant of pi over 2. Secant goes with cosine. So if I do secant with cosine, I need to know the cosine of pi over 2. So the cosine of pi over 2 is 0. Well, when you flip a 0, you get undefined. So, next, we have this one. We have cotangent inverse of x equals 2 pi over 3. X equals the cotangent of 2 pi over 3. So we go to our pi over 3 reference. Tangent is root 3 over 1, which means cotangent is equal to, if you flip that, 1 over root 3, and it's in quadrant 2, so it's going to be negative. So that's what's going to happen there. So that's just solving, that's going forward. A lot of you guys are okay with that as long as you remember your unit circle. Last thing we're going to do, and I'm not going to really type these in, I want to just show you. Make sure your calculator's in radian mode. To type this into the calculator, oh, hold on one second. Sorry about that, my OneNote likes to crash every once in a while. So again, we need to provide answers in radians. All you have to do to type in the calculator is, instead of cosecant inverse, since we don't have that button, we do have sine inverse, and then we have the reciprocal. So you just type in calculator. Alright, and then same thing for this one. The only thing that's weird about this one is if it's in the different quadrant, you'd have to change it, but we're not going to do one of those today, so we're not going to worry about that. Alright, so I'll let you guys just type those in and see what you get, and then you can double check with me in class if you were not here. And that's it. Those are secant, cosecant, and cotangent, the inverses of those. Hope you guys have a good day. I'm recording this the day before a big snowstorm in 2019. We'll see what happens. Maybe we won't have one, maybe we will. See you later.